Values. Your book says many times in math, particularly algebra, graphs, and number lines will aid your understanding of algebraic ideas. So we all understand, and we have studied before, what a number line is. The zero in a number line is always the origin, okay? That basically lets us know it's a number line. Now, you see a thermometer there in your book, and when we go up and down, we also have a zero. So if you think about it as sea level, or you think about it as a thermometer, we've got zero right then and there, okay? The point at zero being the origin, all numbers to the right of the origin are positive, right? Now, do you say that you're a positive 13 years old? No. We just understand that you are, okay? So in life, we don't typically say I'm positive this or whatever, but in math, we use positive and negative numbers. And in life, we also use positive and negative numbers. We realize that if we're talking about the temperature, we might dress differently when it's negative 13 below as opposed to 22 degrees, okay? That's a big, big difference. By the way, kind of a little tricky, isn't it? The difference between 22 degrees and 13 below, well, 22 down to 0 is 22, but we go down another 13, so 22 plus 13, class? 35. So that's a difference of 35 degrees, isn't it? So the reality is the positive and negative numbers, we have to know how to add and subtract those. We'll do those in some lessons to come. But if you look at your book, you'll find out that the positive numbers to the right, negative numbers to the left. And if we end up maybe graphing them, if I just say to you, I want you to graph a 2, okay? What you would do is we would have 1, 2, 3, 4, all right? Negative 1, negative 2, negative 3, all right? Negative 4. When we write a number line, our graphs are equidistant from each other, the points, the hash marks, right? I mean, that makes sense. We wouldn't want to go way out, or else it would be off and not to scale, okay? Because it does represent a value of distance, doesn't it? Just take a ruler if you want to measure something, or maybe the ceiling, or whatever it might be. So if we graph a 2, all that means is we put a circle right on the 2, okay? If we graph a negative 3, that means we would put a circle on the negative 3, right where the intersection is at, okay? Helps you to know? All right, good. Now, let's take a look here. Flip the page. It turns out that we graph the following points in the example. You see it? All right. Oh, look at letter D. They're going to throw you through a loop here, aren't they? They're going to give you a fraction. Let's say we graph 2 2/3, all right? That's not in the thing, but I'm just making it up. 1, 2, and we're going to go 2/3 of the way, okay? So 2/3 of the way, well, there's about 1/3 right there. We divide it in how many? If it's 2/3, how many sections? 3 in our mind. So this is the first 1/3. This is the second 1/3. So there is the circle. 2 2/3, okay? Now, we know that, and that's easy and natural to do when we're going with positive numbers or we're going right. It isn't always natural per se when we do it negative. So let's say we were doing a negative 3 3/4, all right? So a negative 3 3/4. Well, here's 0 to 1 is 1. 1 to 2 is 2. 2 to 3 is 3. But then we go 3/4 more, don't we? Right? But which way are we going, right or left? We're going left. So from this 3, we want to go 3/4 over. So how many sections? What's the denominator in 3/4? 4. So in our own mind, between 3 and 4, we're cutting it in our mind 4 different times, right? Well, how can we do that? Well, easily we cut it in half there, and then we cut it in half again. So 0 to negative 1 is 1. Negative 1 to negative 2 is 2. Negative 2 to negative 3 is 3. And a negative 3 to a negative 4, 3/4 of the way puts our dot right here. Negative 3 3/4. Okay? It doesn't put our dot on the 1/4. It's the distance from here to where? 0 or the origin, correct? All right? So the full distance is 0 to a negative 3 3/4 going left. All right, got it? Perfect, awesome. All right, now, your book goes on to give examples about a thermometer, or we could say sea level, or something like that. And the same is true for what we're doing here. Let's say this is 1, this would be 2. We can just kind of do it here, negative 1, all right? Negative 1, negative 2, all right? So if we're doing 1.5 positive, we go up 1 and then another half. And there would be our dot, 1 and 1/2, it's positive. If we do negative 3/4, what are we going to do? We're going to start with 0 and go down 3/4 of the way. So not half, not 1/4, not 1/2, but where would 3/4 be? About right here. All right, so we're going to put a dot right on negative 3/4. Okay? Fair enough? We got it?
Can I ask a question?
You can, but I'm recording right now. Hang on one second. All right, so negative 3/4 is right where we're at, down at the bottom, and that's what we end up having, okay? All right, and then in the last example, let me just help you understand. The only thing you need to know is absolute value ends up being the lines on both sides. So watch this. Absolute value is easy. If I have a negative 11, that's the absolute value. I've got 2 lines on both sides of it. So what is the absolute value of a negative 11? The answer is always positive. Okay, got it? It's always positive. So the negative 11, the answer becomes 11. So we just write it like this. Okay? What is the absolute value of a positive 11? Already a positive 11. Okay? That's all we need to know there. I think that's pretty easy to understand. Let's see, if we go negative 3.5, absolute value, it's going to be a positive 3.5, or positive 3.5, all right? And then also, the opposite of a number is easy to do. Watch this. Here's the opposite of a number. The opposite of a 4 is it's positive, so to make it opposite would be a negative 4, okay? What's the opposite of a negative number? A positive number. So the opposite of a negative 3.2 would be a positive 3.2, okay? So those are the concepts we're going to do, and in your homework, we'll drive that home a little bit with some examples of each one, and I think you'll get a good understanding of what it is we're doing. We're laying the foundation for positive and negative numbers and for you to be able to add and subtract them correctly, because sometimes it does get a little confusing when you put negative and positive, all right? But you just got to remember, all right, what happens? Somebody borrows $1 from you. I go up to one of my students and I say, hey, can I borrow $1 and get a candy bar? Okay? So what do they do? They give you $1, you go to the counter, you open that candy bar, and you're just enjoying it, having yourself a good time, but you remember, I gotta bring $1 tomorrow. So technically, your life represents this number. Negative, right? Because you're technically negative $1, because you owe somebody, all right? Well, you come back the next day, and you find out you have 2 quarters in your hand, and you forgot to bring $1, but you happen to have 2 quarters. When you pay them 2 quarters, you would say to them, I owe you what?
50 cents.
I owe you 50 cents. Now, the person that you're paying to, they probably appreciate that. I mean, they want their $1, but hey, kind of nice to at least have half. You're working on it, right? So if you have a negative $1 and a positive 50 cents, well, you have a negative 50 cents. And what we're going to do in some lessons to follow is just teach you about good positive and negative numbers in life. You got to really get a good handle on that in math and what you're going to do, okay? All right, thank you.